Okay, so let's go ahead and finish up 4.2. This is 4.2 part 2. With binomial distributions, for us to find the mean, the variance, and the standard deviation, we're actually going to use our Casio calculator. Let's add Casio here. And here are the formulas. So for the mean, we're just going to take n times p. You could see from part 1 that we find n, p, and q from the problem. For the variance, which is sigma squared, we're going to take n times p times q, pop that in our calculator. And finally, for the standard deviation, we're going to take the square root of the variance. So take the square root of n times p times q. And these are on your formula sheet as well. All right, so in Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. So that's going to be our P. P is equal to 0.56. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret the results. So there happens to be 30 days in June. So N is 30. P is 0.56. That was given to us in the problem. Q is going to be 1 minus P. So that would give me 0.44. And then I'm going to come over and just calculate using the calculator. So for the mean, we're going to take N times P. So that's going to be 30 times 0.56. If you put that in your calculator, you get 16.8. So the mean is 16.8. For the variance, we're going to take N, which is 30, times P, 0.56, times Q, which is 0.44, and that gives us 7.4. So that is the variance. And then finally, for the standard deviation, sigma, we're going to take the square root of the variance. So the square root of 7.4 gives me 2.7. Okay, so I now have the mean, the variance, and the standard deviation. And so therefore, on average, there's going to be 16.8 cloudy days, right? Because that's my mean. And I'm going to have a standard deviation of 2.7. So if I draw this on a number line, we did a little of this in chapter 2, I put the mean in the middle, that's 16.8. On each side, I'm going to add the standard deviation or subtract. So on this side, I'm going to add 2.7 each time. On the other side, I'm going to subtract 2.7 each time. So I'm adding the standard deviation or I'm subtracting the standard deviation depending on if I'm on the right or on the left. All right, let's try another one. So it says that find the mean, variance, and standard deviation of a binomial distribution. So you're going to go to your formula sheet, find the formulas. I put the formulas right here for you. They gave me N, which is 50. They gave me P, which is 0.3. Remember that Q is going to equal 1 minus P. So in this case, that would be 0.7. So for the mean, I'm going to take the N of 50 times P of 0.3. That gives me a 15 for the mean. For the variance, I'm going to take N of 50 times P of 0.3 times Q of 0.7. And that gives me 10.5. So that's the variance. And then finally, for the standard deviation, I'm going to take the square root of the variance. So the square root of 50 times 0.3 times 0.7, that gives me 3.2. That is my standard deviation. Right. So I wanted to show you this one because otherwise it's going to frustrate you in the homework. Sometimes it's not a binomial distribution, and then you're just going to say it's not a binomial distribution all the way along. So this one is a state lottery randomly chooses 5 balls numbered 1 through 39 without replacement. So as soon as I see that without replacement, I know that this is not a binomial distribution because the probability is going to be different every time. If I run it through that machine and I grab a ball with the number 37 on it, but I take it away, now my probability has changed. So that's not going to work. It is not a binomial distribution, and that's because the probability of success is different for each trial. And so along the way, as you work your way down, you're going to just keep saying the experiment is not binomial, the experiment is not binomial, and you're going to click all the way through with that. Okay, so we have 55% of consumers prefer to purchase electronics online. Awesome. That means that P is equal to 0.55. You randomly select 8 consumers. That means N is 8. And we want to find the probability that the number of consumers who prefer to purchase electronics online is exactly 5. So that would be this first one. We're going to use StatCrunch. We're going to use calculator binomial. We're going to put in N equals 8, P is 0.55, and we want the probability that X is equal to 5 because it says exactly 5. Hit compute, and out pops the probability. Okay, on the next one, we want the probability that it is more than 5. So more than 5 is greater than 5, not greater than or equal to, greater than 5. So again, we're going to go into, or you're still in that window, right? Calculator binomial. You have your N equals 8, P equals 0.55, put a greater than sign here and a 5 here, and the probability would be 0.220 that greater than 5 people prefer. Right, at the last one, it says at most 5. So that's the tricky one. At most 5 means that we want 5 or less. And so we would use X less than or equal to 5. Everything else stays the same. And notice your probability goes way up and you're at 0.780. All right, we did a problem like this earlier. I just wanted to show you what it looks like in the homework in MyStatLab. So 72% of adults want to live to age 100. That means P is equal to 0.72. You randomly select 5 adults and ask them whether they want to live to age 100. I don't know. If I'm healthy, I guess so. Then we have to create this probability chart. So remember, you're going to use calculator binomial. You're going to put in the N, put in P, and then you're going to have the probability of X equal to 0, X equal to 1, X equal to 2, all the way down, right? So you're going to just keep changing the number inside the parentheses to create this table. At that point, take a look at the data and you're going to pick a graph. So for the most part, the bars are all climbing until the very last one. And so that means that D would work. And then it's going to ask you if it's symmetric, skewed right, or skewed left. So since the tail is over here to the left, this one is going to be skewed left. So let StatCrunch do the work to help you fill in the table. And then from there, pick your graph and see if it's skewed or if it's symmetric.